So for the past 5 years or so now, or 5 seasons, we've been looking at seeding rates of several different varieties, honing in and looking at the optimum wheat seeding rates for the spring wheat varieties that you guys are growing in your fields. So we've been at this since 2016, and in 2020, we dropped our seeding rates back a little bit because of our yield responses to the data we got. So previously we had been looking at seeding rates of 1 million, 1.5 million, and 2 million live seeds per acre. We usually ended up with not a lot of differences between any of the rates. So we decided to rock back our seeding rates a little bit to 3/4 million, 1.25 million, and 1.75 million plants per acre, live plants per acre. So the varieties we focused on this year were 9590, Valda, and the new Minnesota Washburn variety. And previous years, we've looked at Bowles, Lang, Linkert, and Shelley. Our planted seeding, or our live seeding rates, took into account our live seeds, our germination percentage, and the number of seeds per pound per seed lot from the seed tag for each trial. So we were calibrating to make sure that we're planting the correct number of live seeds per acre. And then plots were harvested by weighing each pass from each plot in a weigh wagon or calibrated grain cart if the producer had one. And so we'll look at some of our basic 2020 data here for a little bit, and then we've got some economic analyses, new economic analyses that we're able to get some outside help with to look at that I think you guys will find interesting. But first, just to take a look at yield from our 2020 locations. These are just the yields from the individual locations. You can see the location and the variety is down on the bottom there. And yield, or bushels per acre, on our axis. And we can see there was some variation in responses, but even as far as the individual locations went, we didn't have any significant differences in treatments, except at the very end, on the right there at the Red Lake Falls location. We had the 3/4 million seeding rate was significantly lower there, and that it would definitely attribute to weed pressure. We had some noticeably a little bit more weed pressure in that lower seeding rate, which we might expect. We had less canopy cover in that lower seeding rate, and so the weeds kind of took off in those plots. Looking at just our 2020 yields by variety, looking at 9590, Valda, and Washburn. Even when combined across the few locations that we had this year, our 7 locations that we had this year, we still did not. I don't like to say that maybe we have seen some trends. So I try to stick to just, what we found significant differences in. So still didn't find any statistically significant differences in the seeding rate data. We had a final question on stand counts. Yes, we did take stand count data, and that's something we'll get to in just a little bit. Looking at protein, wheat protein was not different between varieties. Although when we combined across locations, that lower seeding rate might have shown a slight bump in protein. And that's something we might expect if seeding rates, if one particular treatment has a lower yield, it should, the plant will have more nitrogen to allocate to protein. So that's not surprising. Test weight, maybe just when looking at our 2020 data, maybe not a slight tenths of a pound or pound differences in test weight, but not something I think we need to worry about a little bit too much here. And so we had the comment about stand stand counts. We did take we took established stand counts and then also stems per acre. And so for this part, I'm going to turn it over to Kyle Jory, who's a research assistant with the U of M Ag Department. I'm going to stop sharing and he's going to take it over here. And he was able to run some kind of response analyses on all of the data that we have collected thus far. So I'm going to let Kyle take it over and kind of explain what he was seeing related to emergence and stand loss and our yield responses too.
All right, thanks, Missy. Yeah, so I, talking with Missy, thought there's quite a bit, she said there's quite a bit of data here, and I dug in to see if I might be able to do some kind of economic analysis. And that involved looking for response curves. So trying to understand how seeding rate affected sand and tillering and of course yield. And we got some interesting results. So I'll run through these with you. This graph that you can see here, those dots on there are actual values that came from the trials. And I have them separated out here by color according to the different varieties. And as you can see, so the axis on the left there is the stand loss. So this would be a measure essentially of emergence. We're looking at, I guess, a reduction in emergence for various seeding rates. You can see a positive trend. So as we might expect, as the seeding rate increases, our stand loss increases. In other words, we get lower emergence or lower amount of emergence. The actual average ended up being about, for an increase of 100,000 seeds, we might expect then about 7,000 fewer plants to get an idea of the stand. Something similar was done with stems. So looking at tillering here, again, when we see an increase in the seeding rate, the number of stems decreases. So on average here, we'd say about for an additional 100,000 seeds, we might result in about 144,000 fewer tillers. And that's an average across all of them. That would be a mean response across all of the different varieties. But I have them separated out here if you're interested to see the variations in the varieties. Now, there are a number of different trials that were done with the different varieties that it's not all consistent. So, you know, when we talk about standard errors and whether or not how confident are we this variety is going to be above this one, I would point out sort of that the reliability is going to depend on roughly how many locations we had. So you can see that on the right side there. We had fewer trials done with Washburn and Lang, for example, than with Linkert or Valda. So take that into consideration when we look at these. But I did separate them out because I know that that's interesting to folks. The other thing that we thought about here is when you have a situation where emergence and tillering indicate essentially a resource scarcity problem, that this might be an interesting economic question. In particular, what would an optimal seeding rate actually look like? Now, I did dig into this and I found some responses for this. Now, the thing to understand is that there's essentially going to be two optimals. So we have a yield optimal, which of course is the goal in most people's minds, but there's also an economic optimal. And as it turns out, they're different. And just as a sort of a spoiler, the economic optimal is less. So you save money if you seed a little bit less. And I'll show you that in a minute. So this is the yield optimal rates according to the varieties. I fitted quadratic. Basically, it's a general linear mixed model across the whole data set. So those dots that you see there are actual data points for the various different seeding rates that were tried. And this is across all the years. And then the yield response there is the yield on the left there. It shows you where they fell. They're colored again according to varieties. So you can kind of see visually where that is. And then I did a mean response curve that did, it was a mixed model. So I had random effects on the farms and on the repetitions. And then I had fixed effects in the years to try to account for any variation that might have happened with the weather. And then I did put in an interaction here with varieties. I did it both interaction with varieties and without, to kind of, if there's some sort of debate over the reliability of because the standard errors are higher on some of these varieties where there were a low number of trials. So if you look in the middle there, there's a curve that says best estimate. That is essentially the, that's the mean response across all the varieties. And the optimal rate on that was about 1.39. Now, that's pretty consistent with extension recommendations. So I feel pretty good about this. When we start separating out the varieties, we see quite a bit of variation in potential optimal rates. 95-90 looks like you can just really push it and potentially get increased yield out of it. Laying, it's the other story. Now, of course, we've also heard recommendations to seed laying less. So as we go down in seeding rate, we might get more yield. Yeah, that's consistent. Would I recommend going down to 0.64? No, and I'll tell you why. I taught math and statistics. I was a professor for like 10 years, and I always said don't predict things outside your sample space. So we had trials down as far as what, 0.75. So yeah, that's pretty low, but you can definitely push it low. There's no question about that. But this kind of gives a general estimate. Again, Lang and Washburn were the lowest number of trials. So those two lower seeding rates, you know, is that really where we want to be for maximizing yield? I don't know. But it sounds like a good reason for us to maybe do some more trials. One thing I did with this then is I thought it might be interesting to dig into the question about profitability. What I did here is I took a fixed cost. Since we're talking about increasing or decreasing a treatment with seed, and seed costs money, we could fix costs across the board. I did that here. I used, I think, 345 was the fixed cost. And I did also fix the total number of seeds per pound, about 13,200. And then I looked at, for various market prices, what could profits look like. And as you can see at the top there, I have the prices that I used for each of the different varieties. And this is roughly where they fell in. You can take from this what you want. I'm not going to say that this is necessarily always true. We know that people will perhaps treat different varieties differently in terms of management. We might have variations in chemical. We might have variations in fertilizer. Again, this is sort of fixing everything else. The dashed line at the 0 here, this would be indicative of your break-even points. So you can kind of see at different market prices, expected market prices, where there's a potential break-even. Yeah, so that's sort of a profit equation. Now, when we look at the profit equation, the next question becomes, okay, well, what's the economic optimal seeding rate? And that's the thing I looked at next here. This is a graph that was generated for different expected market prices. It turns out that the economic optimal, this would be the profit maximizing optimal seeding rate, is going to depend on the price of the seed. It's going to depend on the market price of the commodity. And then the third component is it needs to depend on the yield response to the treatment. So in this case, that would be the yield response to the changes in the seeding rate. And getting those coefficients and the estimates on those coefficients is a challenge. And that was sort of the goal here. Since we had quite a bit of data, I thought maybe we could get pretty close to that. Again, I threw in that sort of best estimate. This would be the mean response across all varieties. As you can see, it right here in the middle. I would remind you that the yield optimal seeding rate was like 1.39, so that would be just a little bit above this best estimate, but it's above for all market prices, which is to say that I guess this is maybe the big takeaway, if I had one to give. You're probably going to make more money if you go under some of these estimates. Seeding less is potentially going to profit you a little bit more. Now, how much less? Where are we at here? Somewhere between 1 and 1.25 is it? It depends on your expectations of market price. Would I say that Washburn and Lang should be seeded, that far under $1 million? No, I wouldn't. Like I said before, that it's just sort of dependent on the reliability of these estimates, but this is where it came out. 95.90. Should we overseed over those recommendations? Yeah, absolutely, right. Should I go up to like 2? Probably not. But we get into that 1.5 mark and around there, and we're probably doing as best we could across, at least in terms of getting that positive yield response with these. So that's about what I have here. Were there any questions that came up? Let me see if I can bring it up.
We didn't have any questions specifically related to this, just the seeding rate in general.
Okay.
So we had a quick comment and question related to nitrogen on the plots and seed treatments and for starter fertilizer. And a comment: increasing the seeding rate would require more nutrients for plant and tiller survival. And yes, and so maybe they commented increasing starter fertilizer or noting the increase in starter fertilizer and whether or not they have seed treatments would also play into this. And that might be a topic for some further research. Fortunately, we weren't able to bring nitrogen into these seeding rate analysis because we don't have beginning nitrogen rates recorded for a lot of the years of the analysis. So that's wishing that we're able to talk about that, but maybe later on. So with